Alright, we're going to show you a couple of science demonstrations. The first one that I'm going to start off with is called balancing nails. And what you're going to need for this demonstration are a block of wood and 12 identical nails, including this one inside the block of wood. Alright, so you're basically just going to try and balance nails like what it's called. Alright, so. Not working. Alright, so now I have a solution to that problem. I'm actually going to show you how you can get the center of gravity of these nails on one single nail. And the trick to doing that is a pattern. So you take one single nail, you lay it flat on the table. You take another nail and you lay it to the right, and then lay another nail to the left. And keep laying them to the left and to the right in alternating directions until you have 4 on one side and 5 on the other. Alright, now that you have that, take the final nail and turn it the opposite direction as the first one we started off with. You pick it up carefully and you try to find the center of gravity. And you balance 11 nails on one single nail. Okay, now I'm going to explain to you how this one works. And the way that this demonstration works is using the center of gravity or the balancing point of the nails. When the center of gravity of something isn't supported, it'll fall over and it won't balance up correctly. So, for symmetrical objects like a meter stick or a baseball, the center of gravity is going to be directly in the center of the object. And for non-symmetrical objects like a baseball bat, center of gravity is going to be towards the headband of the object. And what these nails depend on is the center of gravity of the single nail, the resting nail, to be directly or right below where the nails rest. And if the center of gravity of the nails isn't supported, if you add too many nails to the left or to the right, it becomes unstable and it'll fall down.
Alright, so I'm going to be showing you the spill knot technique. Now, you're going to need a cup halfway full of water with the spill knot. And
let me show you how to do it.
And as you can see, the cup stays in the same place and does not fall. Alright, now you want to make sure you keep it at a constant speed because, this works because the centripetal gravity is acted upon it. So it uses 2 of Newton's laws. Force equals mass times acceleration, and an object in motion will stay in motion unless acted upon by an outside force. Now, the force, the mass is the water in the cup, and the acceleration is how fast I move my hand. Now, if you slow down while you're in the middle of the air spinning the cup will fall, and we'll just have a big mess on the floor. So that's basically how this one works. He's just using the center of gravity
and centripetal force. Alright. Now I'm going to do a demonstration called the surface tension jar. The concepts of this demonstration are cohesion, surface tension, air pressure, and the properties of water. The first thing that I'm going to start off with is I'm going to have a regular screw-on jar, a laminated card, and eventually have another one of these with a mesh screen inside of it and a tray to hold any water that falls. So what you want to do is you want to take the laminated card, place it over the top, and flip it at 180 degrees. And you can see some water is going to fall out, and that's basically telling you that a vacuum effect is going on right now. And what's occurring is the water pressure is coming down as air pressure is trying to go up into the jar, keeping a vacuum right between the laminated card and the water. So if you pull it off, water's going to fall off. Now this is going to demonstrate surface tension. Alright, we're going to do the same exact thing that you did with the other jar. Flip it 180 degrees, water's going to come out. And when the card comes off, the water doesn't come out. Can I have someone come up here? Anyone? Come on, man.
Take off your hat.
Alright, stand right there. Alright. Don't press it over there. Look up. And it won't come out. The only way that the water will come out is if you tilt it to the left or to the right. And that's because the surface tension is disturbed and the water comes out. Alright, now I'm going to explain to you how this little demonstration works. This one works without the screen, mesh screen in it. Works with air pressure. And like I said, there's a vacuum effect going on with air pressure going up into the jar and water pressure coming down. And the surface tension works the same way, but with surface tension, there's hundreds of little water molecules that get stuck inside of here, and it basically keeps the water from coming out. And as you tilt it to the left or to the right, the water just falls out. The surface tension is disturbed, and that's basically the surface tension jar.
Alright, so this is called cloud in a bottle. Now what we're gonna do is make a cloud inside this little bottle right here. So you need a pump, bottle, 1 liter bottle, and some alcohol. Now,
This thing's not working right. Okay, the first thing that you want to do is we're going to first pour alcohol in the bottle, and we're going to just pour enough to fill the bottom of the bottle. Alright, you poured enough so that the base of the bottle is filled. Now what we're going to do is I'm going to place my hand and I'm going to get the water vapor, any liquid inside and around the bottle. What we're going to do, I'm going to place the cork and we're going to apply air pressure. Alright. 5 times. There you go. You get a nice cloud. As you can see, squeeze it out. Now we're going to add 10 pumps.
Now the more pumps you add, the bigger your cloud will be.
As you can see, as he adds air pressure, the cloud starts to disappear, which means that all of the water particles or the alcohol is being compressed. And you get a really better cloud than that. Okay. Now I'm going to explain to you how the cloud in the bottle works. And the cloud in the bottle works using condensing and simple properties that we have in our clouds today. And basically all that we did is we applied air pressure. So as we compressed the bottle, all of the molecules squeezed together, and once it released, it rapidly expanded, making the temperature in the bottle cool at a rapid rate, and also condensing. And by condensing, you get a cloud. And that's how the cloud in the bottle works. The condensing.
Alright, so what I'm going to show you right now is called the smashing thermite reaction. Now, you're going to want to make sure that you have safety goggles and gloves, because it's dangerous. So what you're going to want to do, you're going to want to kind of Alright. If you keep on doing it, you're gotta make sure that you keep moving it around so you get better reactions from other sides. Now, the way this works is iron has a melting point of 1,530 degrees Celsius. Now, this reaction is an exothermic reaction that causes the iron to melt at 2,200 degrees Celsius. So that's basically how it works, and
All right, take that off. Now I'm going to demonstrate and explain to you how the T-Bot 2 hydraulic arm works. And first I'm going to demonstrate and move it around, and all this is doing is pushing water pressure to another syringe to move a certain part of this robot. Okay, so Alright, the T-Bot 2 hydraulic arm works by swiveling left to right on its axis, and the axis connects from the swivel base to the mid-arm, and the mid-arm connects from the mid-arm to the fulcrum, and the fulcrum connects to the grippers. And as I pull the syringe, it pulls in the water, moving it left to right. Also, if I were to fill this syringe, the back part would push and it would turn it to the left. Okay? And now if I were to squeeze this, it'll go up, it'll go down, and this is with the fulcrum, and the fulcrum connecting to the grippers. And that's how the T-Bot 2 works using hydraulics. No electricity. Good job. Yeah. Alright, we added this demonstration because we thought it was pretty fun and simple. Alright, I'm having my partner tie up the other end of this bag. And what this demonstration is called, it's called the Bernoulli's bag. And this is using Bernoulli's principle, and he was some very old scientist that worked on properties of air. And what we're gonna first do is create drop. I'm first gonna try to fill this bag, blowing air into it. All right? So I'm gonna start off with 5 blows. All right. And that's what we get with 5 blows. Now I'm gonna blow 10 times. Let's see how much air we get to fill into this bag. Now, I filled up the bag halfway. Alright, pretty simple, huh? Alright. Now I'm going to actually use Bernoulli's principle. And I'm going to have Jeremiah hold the other end of the bag. And we're going to see what the Bernoulli's principle does. Okay. Instead of putting your mouth close to the bag, you blow from a distance. Allows you to blow up the bag with 1 blow instead of taking 10 blows to fill it up halfway. And the way that this works is when I have it close to my mouth, the low pressure from my mouth is going into the bag, just allowing the air from my lungs to enter the bag. But when I blow from a distance, it works as if, say like someone was pushing something into the bag, all the air around it also follows the air coming from my lungs. So I blow from a distance. It's not just the air from my lungs, it's the air around, the high pressure around, also following it and blowing up the bag. And that's when most. Now, Jeremiah and me are gonna partially do the magnet train.
Alright, so this is called the magnet train, and what it is just simple magnets. Under here there are magnets that are opposed to the magnets inside the strips.
There's a magnetic strip that goes in here, and this is using the simple properties of magnets. So this is facing north, and those are also facing north, so they're attracting each other. Less friction to occur, and basically, yeah, it's basically just floating.
Right. So now there are wires that connect to the metal. So when we turn it on, there we go. All right. So
Let's do it one more time.
all right. So the wires act as they transport the energy to the little fan, which makes it move, and it'll just move down the strip. Like these magnet trains are mostly found in Japan, and this is a generator which causes the magnet train to work. Like it gives it its energy, which would give the wires the energy to power the fan. So that's basically this magnet train.
Alright, lastly, we have a demonstration called Old Foamy, also known as elephant toothpaste. You guys probably have seen this a lot. What we're going to do, we're first going to add some soap. We already have hydrogen peroxide in here, which is also going to help with this reaction. And we're going to add food coloring just to make it fun. Alright. Now we're going to add the sodium iodide to the solution and step back.
You want to make sure that you dump all the sodium iodide all at once. It's going to start fast.
Good
Yeah, that's that.
And therefore, if you guys can see steam coming out of this, it's really hot. It's nice for your hands when it's cold out. There's an exothermic reaction occurring here, and there's also a catalyst in this demonstration. And a catalyst is something that decomposes something or allows a reaction to occur at a rapid rate. And what the sodium iodide that was in here did was it allowed the hydrogen peroxide to decompose rapidly, creating a reaction. And the soap also helped by getting the little foam effect. So it's really hot, and don't touch it. Thanks. That's what we have for you.